The title is bounded buffer problem. We also call it as producer-consumer problem. This is one of the classic problem of synchronization. Bounded buffer problem is also called as a producer-consumer problem. Is one of the classic problem of synchronization. There is a buffer of n slot, and each slot is capable of storing 1 unit of data. There are two processes running, namely producer and consumer, which are operating on the buffer. Please look at the buffer. We have a buffer of n slots, and if the buffer slots is empty, the producer can produce and fill the particular buffer. As well, if the buffer slot is full, so that the consumer can consume the data from the particular buffer. Here, the producer tries to insert a data into an empty slot of a buffer, and consumer tries to remove the data from the filled slot in a buffer. And then the producer must not insert the data when the buffer is full. As well, the consumer must not remove the data when the buffer is empty. And the last, the producer and consumer should not insert and remove the data simultaneously. This line is more important. The producer and consumer should not insert and remove the data simultaneously. So the synchronization will happen here. And here M is representing a binary semaphore. It's also called as a mutex, which is used to acquire and release the lock. Empty is a counting semaphore whose initial value is the number of slots in the buffer, since initially all the slots are empty. Full is a counting semaphore whose initial value is set to 0. We have two processes. One is a producer, other one is a consumer. Here is a simple code for a particular producer. Here do wait of empty. Here the meaning is wait until the empty is greater than 0 and then decrement empty. Where we are using the atomic operation wait and signal. Wait is always used to decrement, as well as signal is also always used to increment. Right from the semaphore we saw wait of empty. Empty is a semaphore, counting semaphore. Right here, wait until empty is greater than 0. So if the blocks or the buffer slots are empty, if it is empty, then we can insert a data into the particular buffer. Wait of mutex, meaning that we are acquiring a lock. You know what is mutex? Is a binary semaphore used to acquire or release a lock. So wait of mutex is used to acquire a lock, and then once we acquire the lock, the consumer will not enter into the particular buffer. Will wait for a period of time until it releases. So we can add the data in the buffer. And then signal mutex. Mutex, it's used to release a lock here. You know what is signal? Signal is always incrementing. Signal of mutex is used to release a lock. Once it was released a lock, then the consumer can insert data into the buffer. Here, once it was released a lock, the signal of full is nothing but again a counting semaphore. Signal is always used represents an increment. So it increments the full, because see in wait of empty, we are inserting a value, inserting a data to the particular buffer. So assume that if 5 blocks are already filled, once we insert a data into the buffer, the 6th block is also full. Right. So the signal of mutex is used to release a lock and then signal full. Already the 5 blocks are full. The added data is also in the buffer, so that it increments to 6th one. So signal of full is used to increment, and then while of true. Coming to the consumer problem, do wait of full, wait until the full is greater than 0, meaning that all the blocks in the particular buffer is full, then decrement full. Wait of mutex is used to acquire a lock. Once it is acquired a lock, the producer will not insert a data into the particular buffer. And then once the consumer removed the data from the buffer, we have a release lock using a signal mutex. Once we introduce a signal mutex, it releases a lock. In that case, then the producer can add the data into the buffer. And then we know signal of empty is used to increment the empty and while. So this is the two process, producer process and consumer process. Here we are introducing a mutex. is a binary semaphore, is used to acquire and release a lock representing a synchronization mechanism. And here we are using a empty is a counting semaphore as well as full is a counting semaphore. Here, in producer, weight of empty, weight is always used to decrement. Empty represents weight until the empty is greater than 0. So the slots are empty so that the producer can add the data into the particular buffer. Weight of mutex represents acquiring a lock. And signal of mutex is used to release a lock. Once it was released a lock, the consumer can remove the data from the particular buffer. Here, signal always represents an incremental operation. Signal of full represents increment of one slot in a particular buffer. So it was full. The one slot is full. Coming to the consumer, once again, here the weight of full is representing weight until the full is greater than 0 and then decrement operation. Since weight represents the decremental operation as well, since the particular buffer is full and it is greater than 0, in that case we can possibly remove the data from a buffer. Here we are acquiring a log, weight of mutex, acquiring log. So if we acquire a log, the producer will not interrupt or will not add the data into the buffer until it was removed the data from the buffer. Signal of mutex is also release a lock. Once it was released a lock, the producer can add the data into the buffer. And signal of empty, signal is always used to increment the particular operation. So signal of empty represents increment empty here. So this is what exactly the producer consumer problem, also called as bounded buffer problem.